This conference will now be recorded.
Okay, now in this exercise, what exactly they're asking us to do? In the very first question, you can see that they are saying that find the vertices of the triangle ABC whose sides are given by means of these equations of lines. Okay, means AB is the segment of this line. That's what it means. Okay, BC is going to be the segment of this line, and so on. AC is a segment of this line. We need to draw the graph of these three straight lines, and those three lines are going to intersect each other and they are going to give us a triangle. Okay, so that's it. We need to find out the vertices of that triangle. Okay, so by simultaneously solving these lines equations, we are going to find the coordinates of ABC, okay, respectively. And after that, we are going to show that the triangle is isosceles. So once when we find all the three vertices coordinates, then with the help of the distance formula, we are going to show that two of the distances are going to be equal. So in that way, the triangle is said to be isosceles. So we are going to do this question now. So let's start. And it's too easy to sketch the graph of any straight line, of any linear equation. You just need to focus on the slope, you just need to focus on the y-intercept, and you are going to construct the line. Okay, so there is no such rocket science here. So we just now pick up this question. And that's it. We now pick our very first equation. It is representing our line segment AB. So the very first equation that I am having here is L1, and it is representing my AB line segment. Having this equation, I'm going to transform this equation with respect to the standard linear form, that is y is equals to mx plus c. And from there, we are going to find out the slope and the y-intercept. Okay? So I just shift this minus 2a on the other side and plus 1 over here, so it gives you this form. So y is equals to half of x plus half. That's it. So if I just compare this equation with my standard linear equation, I come to know that my slope is half and my y-intercept, that is c, it is also half. So y-intercept is 0 half. This is one of the points that I know, and with the help of slope I can find out the other point. Okay, so here you see the slope is 1 upon 2. So either you can take this point, this y-intercept point, either you can take 1 unit up and 2 units right, okay, or if you just write like this, you can take this point 1 unit down and 2 units left, because it is also giving you half, right? So you have two ways of getting the points. Okay, so I have just decided to pick up this pattern, and I'm going to draw my graph. But before drawing the graph, let us just figure out the remaining two equations, and then at the end we are going to draw the lines. All right, so this is a coordinate geometry, right? So though we can find out the vertices uh, directly without sketching the graph, we can do that. But this is the intrinsic, or what we say, the etiquettes of analytic geometry, that whenever we find analytic geometry questions, we just try to sketch them first and then try to solve them algebraically. It's like that. So we just pick up our second equation, which is which is this. Okay, and it is giving me 6y equals to minus 7x uh, plus 53. So y is equals to minus 7 upon 6x plus 53 upon 6. Okay, now you see here, this is giving you slope minus 7 upon 6. Okay, and your y-intercept is, though it is here, but it is coming in decimal form. Okay, so how about if I just pick up one point which is having a coordinate in whole number form? That's much better for me. So if I just pick up uh, x value 1, if I pick x value 1, okay, then for example, if I pick x value 1, then y is equals to minus 7 upon 6 plus 53 upon 6. So it is giving me minus 7 plus 53 upon 6. So what exactly it gives you? It gives you 50 and then 46, 46 upon 2, or 46 upon 6. So it is also giving you answer in whole numbers, answer in decimals, I'm sorry. So it is going to be 7.40, so it's giving you 7.6, yeah, 666 and so on. So it is also coming out to be in decimal, so x equals to 1 is not helping me out. So if I pick x value 2, is it going to help me? Because my objective is to get coordinates in whole number form. If it is taking time, then no issue. You can pick up the same thing, the same y coordinate, y intercept, and you can take this along with you with an approximating sense. Okay, so 53 upon 6, it gives you what? 6 eighths are 48 point 50. Again, 8.8 something. Is this what we are getting here? 8.8 something, if I'm not wrong. You can confirm from your calculator what exactly the point is. Okay, so approximately you can take, yeah, so approximately you can take this thing as 0 and 9. Roughly, if we just try to plot the graph on a plain paper, then this point is going to work, and then you can move this point 7 units down and 6 units right, you're going to get the other point. Okay, so it's like that. So, and now we just come to our last equation, which is AC, and L3. So it is having 9x plus 2y equals to 11. Alright, so 2y equals to minus 9x plus 11. So y is coming out to be minus 9 by 2x plus 11 by 2. So my slope is minus 9 by 2, and my y-intercept is 11 by 2, which is 0, 5.5. Okay, this is the point. And you can move this point 9 units down and 2 units right. It is going to give you the other point, and you can move on. So now what I'm going to do, I'm going to sketch these lines. Okay, so I'm going to take 20 units up right, 20 units right left. That's what I'm taking, and I can take 1 centimeter equals to a half centimeter equals to 1 unit. So it's going to work. So I'm going to pick up this here. like that. So all the quadrants are having equal space, like this. And I'm now taking half centimeter equals to 1 unit. I'm just uh, uh, taking a quite wider scale because I don't know where the points are going to lie. Okay, so though you don't need to do this work in the exams, just need to solve it algebraically, but I'm just doing to make you clear that how analytic geometry actually work. Okay. Okay, these are all 10 values. Okay, starting from 1 to 10. These are all up to 10. Okay, now we just pick up our first line, and the y-intercept that it was having in the first was 0 half, and I'm going to move this point 1 unit up and 2 units right. Okay, 0 and half, I'm going to use another color, this one. The 0 half is coming over here. Okay, and I'm just going to shift this point 1 unit up. So this is my 1 unit up. Okay, 1 centimeter up from this point, and 2 centimeters right over here. This is going to be the other point. But these are the 2 points which I'm having, this one and this one. I'm going to join them, and in default it always gives you a curve, that's why. Okay, now this is it. I'm going to change my color just to make a difference. Just like that. And I've changed the color into pink like that. Okay, now this is a line. Okay, I've selected arrow by my in default, so we just forget about this arrow. Okay, it's nothing over here. And now I'm going to pick up my second line, and the y-intercept of the second line was 0.9 or 0.88, so approximately I'm taking 0.9, and then I'm going to shift it 7 units down and 6 units right. Yeah, so 0.9 is here, almost, maybe a little below. I'm just picking up 0.9. Okay, and 7 units down means 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6 here. Okay, so in the line of my 2, I'm going to highlight the point. This is it. Okay, and then I'm going to join these 2 points and change the color, and I don't want arrow. I don't want arrow at all. So I'm going to do this. Now, erase this out, and now I'm going to draw my line with a different color. Okay, and then my third point is 0, 5.5, and it is, I have to move this 9 units down and 2 units right. Okay, so 0, 5.5 is here. This is 0, 5.5. Okay, you can just like that. Exactly in the mid of your 5 and 6. This is 0, 5.5. I'm going to move this point 9 units down and 2 units right. You see here, this is half centimeter length, so half centimeter below it's going to give me 1 centimeter or 1 unit. Okay, so you have to go accordingly with respect to the position of the point. So from here to here, this is 1 unit. And I again forgot that how many units I have to move. Okay, 9 units. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the position. And then 2 units right, 1 and 2. That's the point. Okay, and then I'm going to join them, and this is going to provide me my third line. I need to extend this previous line here a little, and then I'm going to join these 2 points. Okay, and I'm going to change the color into blue, and that's it. So you see, this blue line is representing your AC. Okay, this is AC. This is representing DC, and this is representing your AB. Okay, the intersection of AC and DC is giving you point that you call point A, point B, whatever you want to name. So this is the intersection point, I call it A. The intersection of AC and AB is going to give you another vertex B, and the intersection of your BC and AB line is going to provide you the third vertex C. So this is it. So you see the intersection, let me just write down here the compositions. AC and BC. You need to solve these 2 equations and get the coordinates. Okay, it's going to be the coordinates of your point A. And then you need to solve your BC and AB. This is going to give you coordinates of your point C, and similarly solve simultaneously your AB and AC equations to get the coordinates of your third vertex. That's how we go. So I'm going to do just one simultaneous calculation and get the coordinates of my vertex A, and the remaining 2 equations pair you have to handle by yourself, and then you need to tell me the vertices. Okay, so get active now. I'm going to pick up AC and BC. So let me just shift this question a little right side so that I can make a nice coordination. Okay, there you go. That's it. I'm picking my AB and my BC. And I have just decided to eliminate my y here. Okay, so 7x plus 6y equals to 53. And I need to eliminate my y, so I need to multiply this equation entirely by 3 in order to make the coefficient same. So it is 3x minus 6y equals to minus 3. Then I'm going to add up these two equations, and in this way y get eliminated. I'm having 10x equals to 50. So x is coming out to be 5. Okay. And then you can pick up any of these two AB or BC equations to get your y coordinate. I just pick up my first equation of AB, and it is giving me 2y equals to x plus 1. So it's going to be 2y equals to 6. So y is coming out to be 3. Okay. So this thing tells me that the coordinate of my A point is 5, 3. I hope it's clear. Okay. I repeat that I am not asking you to sketch this graph. I just sketched it because just to make you clear what exactly the concept is running behind this calculation. Okay. Why we are actually solving these two equations in a pair form. What's the reason behind? That's why I sketched this. Okay. So now solve BC and AB equations. They're right in front of you. And get the coordinates of C and then D one by one and tell me what they are.
This conference will now be recorded.
So you can see these are the coordinates here. So we have just explored the vertices coordinates, and now in the next part they're just saying show that the triangle is isosceles. Okay, so find out the length of each side with the help of your distance formula, and I'm just going to write here. It is having coordinate this, B is having coordinate 1, 1, and C is having coordinate 5, 3. Okay. Now in order to find out the distance of your AB, I'm just going to use my distance formula. And you know that well now, so there's no need to write again and again. So my x1, y1 are the vertices of my A, and B vertices are x2, y2 here. So it is giving me 1 plus 1 whole square plus 1 minus 10 whole square. So it is giving you 2 square minus 9 square. So it is giving you 4 plus 81. So it is giving you root 85 units. This is the length of your AB line. Okay. In the same manner, I need you to find out the length of your AC and BC just like this, and tell me what they are. This time B coordinates are going to behave with x1, y1, and C coordinates are going to behave with x2, y2. Okay. Just giving you root 20. The length of your BC is coming out to be root 20 units. Okay, or 2 under root 5 units. Now what is left now is AC, so I can do AC working here, and so do you. And this time A coordinates are x1, y1, and B coordinates are x2, y2. Okay. C coordinates, sorry. X5 plus 1 and this is 3 minus 10. So this is giving you 85 as well. So you see AC and AB, they are having the same length, that is 85. So AC and AB, these two sides are same, and the graph is also authenticating the equality of these two lengths. So therefore, as the two sides are having same length and the one side is having different length, this is the therefore isosceles triangle. So AB is equals to AC, which is root 85 units, and that's how you end up. You can see that it is written over here as well. Okay, they have just changed the vertices positions. It doesn't matter. Just look at the values; they are fully correct. Okay, you can swap the vertices here and there. Doesn't matter. Okay, so that's it. And the equal sides are having 85 square root value. That's it. It's correct. Now we move to the next question, and the next question says that what exactly it is asking me to do. Two sides of a parallelogram are formed by parts of these two lines. These equations are given to us. Okay. Show these two lines on a graph. Now here they're asking you to construct the graph. As I've told you how to sketch the graph in the previous question, now the thing isn't new for you now. Okay, you can easily manage this. So now we go back to the board and try to pick up these two equations. One of the equations is 2x minus y equals to minus 9. Okay, and my second equation is x minus 2y equals to minus 9. Okay, transform your first equation with respect to your with respect to the standard linear form. So it is giving you 2x plus 9. So this tells you that your slope is 2 and your y coordinate is 9. So the point is 0, 9, that you can move 2 units up and 1 unit right in order to get the other point. In this way you can sketch this line. In the same manner, you just move here. 2y is equals to x plus 9. So your y is coming out to be 1 upon 2x plus 9 by 2. So my next slope, slope of this line is half, and c is 9 by 2, that is 4.5. Okay, so one of the point is 0, 4.5, and when I move this point 1 unit up and 2 units right, I'm going to get the other point, and this way I can sketch this line as well. Okay, so let's do this. And they are actually going to provide you a situation like this. Okay, it's going to look like this. That is going to help us in constructing a parallelogram. Okay, so let's try to sketch this now. If they provide you simply a plain paper, that how you which quadrant you are going to focus more, you can see that these two y-intercepts that I've just obtained, they are all positive. X and y, both coordinates are positive in both these points. Okay, so and once when you translate these points with respect to 1 unit up and 2 unit right, or 2 unit up or 1 unit right, they're going to situate, they're going to be still in the first quadrant, you can see. So you have to focus on the first quadrant. So sketch first quadrant here, and I am going to draw my arrow this time. my x-axis and my y-axis. Okay. You can take 1 centimeter equals to 1 unit or half centimeter equals to 1 unit. It depends on the space that is provided to you in the exams. Okay. So on that basis, you have to expand or you can shrink your scale. So I'm taking half centimeter equals to 1 unit on the y-axis and 1 centimeter equals to 1 unit on my x-axis. I can do it like that. Okay, just for security, I'm just taking 8 units on my x-axis. Okay, and over here, my point is 0.9, and which I need to shift 2 units up. So I can take 12 units on the y-axis, okay, because this 9 point is going to be moved 2 units up, so it should be on the 11, 0, 11. So I need 12 units almost. I can take half centimeter equals to 1 unit, so 6 centimeter long line will easily work here. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, just mark the values here. Okay, now you see this is my point 0.9 that I need to shift 2 units up and 1 unit right, so it is going to locate here. Okay, I'm going to join these 2 points and I will get my line, which I can extend beyond on both sides. That's the line. This is my L1. Okay, and now I'm going to pick up my 0, 4.5, this line here in the mid of 4 and 5, and I'm going to move this point 1 unit up. So 1 unit is here, 1 centimeter. From here to here it makes 1 centimeter. So 1 unit up and 2 unit right. 1 and 2 here. Clear? First line over here. I'm going to join these 2 points. I have to intersect these 2 points. So on that basis I will extend as long as they get intersected like this. Okay, so I can change the color of one of my line like this just to make a segregation, and this is your L2. Okay, this line is your L2. So these are the 2 lines, and you can see if I just try to sketch like this, I'm going to get my parallelogram. That's the story going on actually. So now you see what next thing they are asking me to do. They are now going to ask me in the next part that find the coordinates of the vertex where they intersect. So just simultaneously solve these 2 lines and get the point of intersection, which is this. Okay, so you need to find out the coordinates of this point. Okay, I call it point A. Alright, so I'm going to simultaneously solve these 2 equations in order to get my point. So these are the equations so provided to me. Okay, and I just I can eliminate either x or y, whatever I want. So I just decide to eliminate my y. Okay, so solving equation 1 and 2. That's the part 2 I'm doing here. So in order to eliminate y, I have to make the coefficients of y same, so I will multiply my first equation with 2. Gives me this, and then I write my second equation as it is. Both signs are same, so I'm going to subtract these two equations. It's 3x equals to minus 9. Am I right? So x is coming out to be minus 3. Now you can pick up any of these two equations you want to get your y. So I pick up my first equation, this one, and 2y is equals to x plus 9. So 2y is coming out to be minus 3 plus 9, that is 6. So y is coming out to be 3. Yeah. So
Isn't
y,
it minus 27? Like minus 8 is minus 9.
no, you have to focus on this sign and on the change sign. So minus
Okay.
plus minus.
Okay.
You are going to write the sign of the biggest number. You see, this is the, for the second equation you're going to focus these change signs, and for the first equation you're going to pick up the original signs. Are you getting me? Then you have to figure them out.
Yes.
Otherwise I won't be able to eliminate y in that way if I focus on the previous signs. Okay, so y is coming out to be 3. So the coordinate of this point A is minus 3 plus 3. Okay, this is it. Alright, and then what next they're asking? They have just given us an information that another vertex of the parallelogram is the point 21. Alright, find the equations of the other two sides of the parallelogram. Okay, we just now come here. Where is 21? 21 is here. Okay, if this is 2, if 21 is over here, then it means that I need to extend these two given lines that I've just sketched. I need to extend them a little beyond over here, roughly like this, and this one a little over here. Okay, so you see these are over here. I'm going to focus in this section. Okay, so you can see that if I try to draw a line parallel to my pink line, parallel to my L2, in such a way that it's going to pass through 2, 1. Okay, if I just try to draw a line parallel to my L2 and passing through 2, 1, and I'm going to develop this line in a dotted form because this is presently I'm working on this line. So I'm just, okay, this is it. So I can form the equation of this dotted line very easily, because you see whatever the slope of your L2 will be the slope of this line L3. Okay, and it is passing through the point 2, 1. I know one of the point, I know its slope, so with the help of my point slope form I can find out the equation of my L3. Yeah. So what is the equation, what is the slope of my L2? The slope of my L2 was half, right? So it means the slope of this L3 is also half. Okay, so I'm doing part 3. So M2 is equals to M3, which is half, because L2 is parallel to L3. Alright, I can use my point slope form. The given point is 2, 1. Okay, so this is x1, this is y1. So y minus y1 is equals to m times x minus x1. And then I can do 2y minus 2 equals to x minus 2. So this thing is going to provide me the equation of L3. So L3 is x minus 2y, minus 2 and minus 2 got cancelled, this is equals to 0. Okay, or x equals to 2y. This is the equation of your L3. Alright, that's it. And then I need to find out the equation of the fourth line. Okay, so you see, fourth line is actually going to be parallel to my L1. Alright, and it's a common sense that this line is also going to pass through my 2, 1. Okay, because this 2, 1 is actually so obtained by the intersection of the remaining two lines, that is L3 and L4. Okay, it's like this. And this is my L4. This is my L4. So the intersection of L3 and L4 is giving you this 2, 1. Okay, and this is your beautiful parallelogram. Alright, so that's the story going on. So now I need to find out the equation of my L4. So it is parallel to L1. So L1 and L4 are parallel to each other. It means slope of your M1 is equals to slope of your M4. And we have just evaluated already in the beginning. The slope of my L1 is 2 here. Okay, so L4 slope is also 2. And it is passing through 2, 1. I can form the equation now using point slope form. Y minus 1 is equals to 2 times x minus 2. Get the equation. Y minus 1 is equals to 2x minus 4. So 2x minus y minus 3 equals to 0. This is the equation of your L4. Okay, both equations are now known to us, L3 and L4.
Yeah.
What is now left? We need to find out the fourth vertex, maybe whatever they're asking. Let's see what they're asking. Find the coordinates of the other two vertices. If I call this point A and this point as B, now I need to find C and D coordinates. Okay, so C is obtained by the intersection of L4 and L2. Okay, and D is obtained by the intersection of L3 and L1. Okay, so I just minimize my font so that it is going to cover each and everything here, like this. Okay, so I'm going to write down my L3, L1 and L2 right below each other so that you can easily manage these equations. And then I just write over here in the box that I'm getting my point C by the intersection of my L2 and L4. Solve these two equations, get the coordinates of your C. Okay? And D is obtained by the intersection of your L1 and L3. Solve these two equations, get the coordinates of your D. Do it right now.
Okay.
This conference will now be recorded.
Okay, I just did a calculation here for your so you can tally your work with mine. Okay, so I just solved equation L2 with L4 to get my point C. Okay, and I told you that C is lying in the first quadrant, means X and Y coordinates both are going to be positive for the C. Okay, we just did this over here. You can see here now. Okay, this is my L2 and this is my L4. These are the two equations. I just decided to eliminate my y variable. You can eliminate x to your choice. So with that respect, what I did here, I have to make the coefficients of my y same. Okay, so I multiplied my L4 entirely by 2, and then I can see that signs are same, so I subtracted these two equations and I just got my x, value of my x. Once when I got x, I substituted it in equation number L2. Yeah, I did. I used L2. You can use L4. It's your choice. I got my y, which is this. In this way, I come to know that the coordinates of my C is 5, 7. All right. In the same manner, I solved my L1 and L3 here. I did the same working and I got the coordinates of x and y as -6 and -3. Both are negative, which completely authenticates the position of your D, which is lying in the fourth quadrant. You can see here. Your D was lying in the fourth quadrant.
Yeah, I understand.
If I extend this line a little ahead, you can see that this point is this D is lying in the fourth quadrant. So this is it. That's how we just got the remaining two vertices values, and that's how we end up this question. Question 3, question 4. Read by yourself and tell me, do you need my help here? If you need my help, I'll do it. Otherwise, you can manage it by yourself. Here you see all the 4 vertices are given to you in question 3, right? And you need to find out the equations of the diagonals AC and BD. So they haven't asked you to sketch these points. For your convenience, you can sketch them in your rough section if you want to. Else, you can simply pick up your point A and C coordinates, use your 2-point form, get the equation of your AC. Similarly, a 2-point form will help you to get the equation of BD as well, because you know the coordinates of B and D too. So 2-point form is the best option to get the equations of the diagonals here. Okay. Now after that, once when you find out the equation of the diagonals, they ask you to show that the diagonals bisect each other at right angles. What is this supposed to mean? Once you have just made the equations of AC and BD, in the next part you need to find out their slopes by comparing them with the standard equation. Okay, get the slopes and then see if the product of the slope is giving you -1 or not. If it is giving you -1, it means AC is perpendicular to BD. Okay, and then the next thing is bisection. Bisection means they are dividing each other into two equal parts. So this thing tells me that if I just try to draw here roughly my quadrilateral, okay, for example, if it is a rectangle, whatever it is, okay, whatever it is, okay, I'm just doing it roughly, and I just draw here my AC and BD diagonals. So this is my AC diagonal, this is my BD diagonal. So you see BD and AC. Okay, in rectangle they don't intersect at 90 degree, they intersect in acute and obtuse form. So if I just try to draw here a parallelogram, it will definitely work. Okay, this is a parallelogram here. This is my AC, that's my BD. Okay, roughly you can see that AC and BD, they are dividing each other into two equal parts, and they are intersecting each other at 90 degrees. Okay, like that. So once when you find out the slope of your AB and the slope of your BD, you multiply them and you will come to know that the product is -1, then you will say that AC is perpendicular to BD. One thing is done, and then you are going to find out the midpoint of AC and BD one by one. Okay, I just write down here the step. In the next step, find midpoint of line segment AC and line segment BD one by one. Okay, separately. Once when you do this, after that you are going to find out the intersection of, in the next step, find out the intersection of equation of AC and BD. Okay, if the intersection point and the midpoint are going to be equal, then you will say that these two diagonals bisect each other, means they intersect each other in such a way that they are divided into two equal parts. Clear? So this is something that you need to do. Find the equations, get the slope, show their product equals to -1, then find out the midpoints of both these lines, then find out the intersection of these two equations, see that the midpoint and the point of intersection are equal, then you will say that yes, these two diagonals bisect each other at 90 degrees. I hope it's clear. Once when you do this, in the third part, you need to find out the lengths of your AC and BD. You know the coordinates, all of them, of all the 4 points. The coordinates are mentioned. Use your distance formula, get the lengths. Okay? And at the end,
Yeah. After we
yes,
get the length, do I add them together or separate?
no, you don't need to add the lengths. You just need to find the lengths values separately in part 3. That's it.
Okay.
Yeah. In fourth part, they're asking you to find what type of quadrilateral is it. You just need to sketch these points, get the shape, name the quadrilateral. Simple as that. Okay. So you
Yes.
can manage this question number 3. Come to question number 4. What they are asking us to do, the line with equations this meet the x-axis at A. Okay. The x-intercept of this line is A. Okay. And the line with equation this meet the y-axis at B. Okay, the y-intercept of this line is going to be named as B. Okay, the two lines intersect each other at point C. Alright, sketch the two lines on the same diagram and then get the coordinates of A, B, C. Let's do it. Okay, now I just write down my lines first of all and get their y-intercepts. My first line is 5x plus y equals to 20. If I just try to write with respect to standard form, this is it. So it tells me that my slope is -5 and my c is 20. You see 20 means 0, 20 is quite far. I have to plot this point quite far on my y-axis. Okay, I need 20 readings for this purpose, and then I'm going to shift this point 5 units down and 1 unit right in order to get the other point. So you can go in this way, it's your choice, or you can pick up any two random points you want by substituting x value 1 and x value 2 like that. It is also your choice. So if I pick up, you have both ways of doing. Okay, either you can go in this way, or you can go that if I pick x value 5, okay, then y will be equals to -25 plus 20, so it is giving you -5. So I can pick up one point this. It's easy to draw on the graph. It's quite close to the axis. So I can pick up this point. Another point you can pick, if I substitute x value 3, okay, for x value 3, y is going to be -15 plus 20, so it is 5. So another point that I can see here is 3, 5. You can pick up these points, get the line, or you can go in this way with respect to slope, y-intercept, and then translate it to get your second point. It's your choice. These points are quite far away on the y-axis. That's why I decided to pick up quite close points and easy to draw points, right? So I pick up this one. And then I just go to my L2. Where is my L2? What is my L2? My L2 is x plus 2y equals to 22. Okay. Okay. So it is to y equals to minus x plus 22. So y is coming out to be minus half x plus 11. So my slope is minus half and my y-intercept is 11, that is 0, 11. So I need 11 units on the y-axis in order to pick up this point, and then I will shift this point 1 unit down and 2 units right in order to get the other point. Either you can go in this way or get some close values just for convenience. So if I pick x value, if I pick up x value 2, then I can get y value 10. If I pick up x value 5, I must use the number that should be divisible by 2 here. So if I pick up x value 6, or 8, then y is going to be minus 4 plus 11. Yeah, so it is coming out to be what? 7. All right, so one of the point is 8, 7, easy to draw. And the other point I can pick up here, if x value is 6, okay, if x value is 6, then y is coming out to be minus 3 plus 11, so it is coming out to be 8. So the other point I can see here is 6, 8. Okay, you can pick up these 2 points and you can draw the line, or you can go with respect to this method. It's totally your choice. Now I am going to sketch these 2 lines on the same diagram. So let's go here, and I need 8 units on the x-axis, positive x-axis, and I need 8 units on the y-axis and 5 units on the negative y-axis. Yeah, so I am going to draw my x-axis in the mid of my y. Okay, okay, now let's sketch the points. I need 8 values on the positive x-axis. The maximum value of x that I can see here is 8. I can take half centimeter equals to 1 unit to pick up all the 8 values in 4 centimeter long length. Okay, and I need 8 units on the y-axis as well, so I'm going to take the same scale on the y-axis too. Half centimeter equals to 1 unit. Okay, now I need negative 5 values below. Half centimeter equals to 1 unit, that's what I'm taking. There you go. Now I'm going to sketch my points. For my L1, I'm picking up 5 minus 5, which is here, and 3, 5, which is here. I'm going to draw these 2 lines. I mean, I'm going to join these 2 points in order to get a line. That's it. This is my L1. Okay, I'm going to extend them beyond as per my need later on. This is my L1. Now I'm going to pick up my points 8, 7 and 6, 8. So 8, 7 is here. 6, 8 is here. Okay. I'm going to join these 2 points. This is my L2, and change the color. And you can see that once when I extend these 2 lines a little far beyond, they are going to intersect each other. Right? So I can remove this little working just for my convenience. Okay. I'm going to extend these 2 lines. You can see that they are intersecting over here. This is my L2. Okay. Calculate the coordinates of A, B, and C. Now you can see that first line intersect the x-axis and it was A point. So this is my first line. It is intersecting the x-axis here. This is my A, and I see that it is giving me coordinates 0, 4, 0. And this line is going to intersect the y-axis. So I need to extend my y. Okay, so it is 9, 10, 11, 12. As far as I can see, it is intersecting the y-axis over here. This is my B, and it is 12, 0, 12. It is having the coordinate 0, 12. And then they have just said that uh, the 2 lines intersect at a point C. Okay, so now you just simultaneously solve these 2 equations and get this point C. Okay, this is your C. So that's what you need to find out. So find out the coordinates of your C and tell me what they are. Do it. Solve the equation L1 and L2.
Um, can I see the equation?
Yeah.
x is equals to 2 and y is equals to 10.
Okay. And then find the coordinates of the point E such that ABEC is a parallelogram. Okay. Let's go here. So I just try to pick up this dotted line and try to sketch it somewhere here. And I just try to draw a line parallel to my L2 and a line parallel to my L1. This dotted line is a line parallel to my L1. I just extend it beyond like this. And a line that is parallel to my L2 and passing through A. Okay, because A is the vertex of your given required quadrilateral. Make sure that should be parallel to your L2. Okay, and I can. You can see that this line, this dotted pink line, is parallel to your L2, and dotted black line is parallel to your L1. Hmm? So they are exactly forming a nice parallelogram, and the intersection of these two dotted line is forming your point E. Okay, so once when you are going to sketch the graph at your side in a correct way, because I haven't calculated exactly, it is 1 centimeter, all these distances among the consecutive points. If they're exactly 1 centimeter, then you're going to get the correct coordinate of your C by looking at the graph. Okay, so I feel that it is going to give me 2 1, the coordinate, if I look at the graph. Okay, and if you are not relying on the graph, then you can check this algebraically too. Okay, you can get the equation of your L3 and L4, simultaneously solve them and get the coordinates, but it's a long method. You have already sketched the graph. Just look at the graph and get the coordinate of your seed. We have just done the modification. We have drawn our L3, we have drawn our L4. We can see the intersection. Just trace the coordinates and write it down. So as far as I've analyzed, it is giving me 2 1. We are going to check this out now. Okay, and I again repeat that my coordinates or my points on the axes they're not accurate because I haven't measured this. Okay, so you are going to draw with exact measurements, you're going to get your answers in much accurate form. So I was doing 2D, question 4. There you go. This is correct. This is something that I asked you to do by yourself. Okay, and part 4 is giving me minus 221. Minus 221. Okay, I extended my lines over here, and they have just extended L2 and L3 and L4 right above these, in the above region over here. It's like they have just done it like this, like, because we can get parallelogram over here as well, and we can also get parallelogram in this region. Are you getting that? So it is going to give me a stuff like this if I just remove this working for my convenience. And okay, and if I extend this line far away here, and this line also far away here, but it is not possible. We can't draw the parallelogram right above here. It's not possible for us, because this is A is one vertex, C is another vertex, B is another vertex. If I try to draw parallelogram over here, I am not going to have all the three vertices available. Okay, I'm just having B and C over here. I need one more vertex as well. So this is not going to be, it's not logical here to extend the lines. So my work was fine, and if I just try to see on the graph, it is giving me the coordinates, uh, 2 1 2 1. That's what I'm getting. Minus 221 doesn't make any sense, because in that case the intersection is going to locate here. This is your 1 and this is your minus 2, and 21 is going to be far away right above here. Far beyond. So the point is going to lie somewhere here, quite far away, and it doesn't make any sense. So minus 221 cannot be the coordinate of your E. E is going to lie in the first quadrant. Okay, it is not going to lie in the second quadrant. Not possible. We can further confirm this through the Desmos graphing calculator as well. It's going to confirm that who is correct. Okay, now this is my line. That's it. And then this is my another line. There you go. Okay, there it is. Okay, let's check it out. There you go. Okay, so you see, this is your B, this is your C, this is your A, right? So if you just try to draw here, if I just pick up this section, try to paste it here. Okay, and I'm going to draw a line parallel to this orange line and parallel to this blue line. I'm going to draw two lines here. Just going to confirm me where is going to be my vertex E. I'm going to draw a line exactly parallel to my orange. Okay, and another line parallel to my blue line and passing through my vertex A. Okay, it is exactly parallel. So this is going to be the point of intersection. This is going to be the point, you can see. Okay, so it is lying in the first quadrant. Alright, so minus 2 and 21 doesn't make any sense. Okay, so that's how you're going to obtain, either use the graph or get the equation of these two parallel lines and simultaneously solve them to get the coordinates. You have two ways of doing. Okay, so graph method is quite easy and quick to get because you have already drawn the graph. So pick up the graph and get the coordinates. It's not so big headache for us. So I hope this is clear that how we are going to get the coordinates of our E. Okay, so minus
Yeah.
221 is not the answer. It's something, I think it's a kind of typo or something like that. Okay, so we'll continue then in the next week where we stop. We'll continue in the next week then. Okay, and after that we are going to have just one more exercise, 2E, and then this chapter will be over. And after this chapter, which chapter you need to start?
Functions.
Functions. Okay, chapter
Yes.
4. Okay, okay, okay then. Allah Hafiz. See you next week.
Allah Hafiz.